Since I am lucky enough to start us off, I want to be the first person to ask a question. You're probably going to hear versions of a lot this week and be thinking about a lot this week. What is it you'd say you do here? What does it mean to be an SRE? This is a question we ask ourselves quite a bit. I've seen it a lot at SREcon. It turns out that we're really not sure what this job is. There's a lot of answers, but one answer that I want to focus on for this talk is that SREs are people who specialize in building and using control planes in complex systems. I have some really bad news. We are terrible at this. We are so bad at this. Building good control planes is hard, and using bad ones is even harder. I'm going to use this time in front of you to share one of the ways that I see us building control planes that could be so much better. We forget to design in feedback, and we set ourselves and others up for failure. All right, so it's central to my point here. I've said this word a couple of times. Not everyone might know it. What is a control plane? As a general rule, what software does is take requests from users, give answers back, right? That's what software kind of does in the modern world. Software that we think of as having that primary job, takes requests from users, gives stuff back, that's a data plane. That's what's on the screen. And then we have all of the many things we use to configure and operate that data plane software. Everything from the configuration of the software itself to setting up and configuring the machines it runs on, its network, all of that management stuff is our control plane. And that's our happy place as SREs, right? It's the things we use to make our software operate well. It's our bread and butter. It's the main thing we do and interact with in the typical SRE job. And given that we build and interact with a lot of this control plane stuff, let's take a look at the user experience that we're building for ourselves. So UX designers and others sometimes talk about this idea of arrows versus hoses. The reason is that a garden hose is way easier to aim than an arrow. Garden hoses come with continuous feedback about your aim. You can see what you're hitting moment to moment, and you can move them around, which allows you to make small adjustments with good information instead of guessing or overshooting or just having this slow latency in between what you do. Shooting arrows with a target, shooting targets with an arrow, other way around, is a literal Olympic sport, right? Shooting targets with a hose is something literal children do. We routinely design the control planes in our systems to be arrow-style UX at best. Send a command, maybe get an ACK that the command was received, and then you can go somewhere else to figure out what's happening in production. We can and do learn to work around this, right? You probably are in the habit of sending a command to something in your system and then going elsewhere and looking at your telemetry to see if it's working. But that's a hack that you've built in yourself that you have to learn, and we have to teach to every new SRE. And we have to teach that to the people who are using these control planes who are not grizzled SREs. And there's a lot more of them. It's going to take us a while to teach them all that. So let me be clear. When I say we're not setting ourselves up for success here, we are causing outages. In the spirit of kind of true blamelessness, if the person working with the control plane took a wrong action and caused or worsened an outage, the problem is the control plane. The problem is not the human operating the control plane. If you're looking for it, you can see this in postmortems. There's some phrases up here that you've probably seen or seen versions of. Words like, I accidentally did this, or we unexpectedly had this system change from this action. We didn't realize that this wasn't working properly. I intended to do this, but instead something else happened. We're looking for surprise, we're looking for misfired intent, and we're looking for some kind of lack of situational awareness. If you're looking for this, you can find this in lots of postmortems. How did our control plane lead you astray is a really useful question that you can ask as part of a blameless postmortem to help find some of these kinds of cases. So again, this matters because stuff breaks. I love talking about outages. That's what I do. So let's talk about some outages. First off, my very favorite example of a terrible control plane with bad feedback. Yeah. All right, really, I have this complaint about all control planes that are intent-based. These are systems where you tell the control plane what you want to say, like, I want 200 pods with this binary in size running. It accepts your desire, and you get feedback. This is good. Feedback is good. We like that. We want to see that arrow. About whether that's a valid and well-formed configuration. Did it accept your command? And then the controller changes production to actually match your intent. Probably. How do you know that production actually changed? Again, where's that feedback loop? What if there's a problem, like there aren't enough nodes to run the pods on, they're failing to start up, they never become healthy? You can find out about these problems, but you have to go ask in another place. Either you have to run additional commands against Kubernetes or whatever you're using, you have to go look at your actual telemetry, you have to remember to do this. You have to build that monitoring on top of the as-designed control plane, either in your own brain or in some other service, and add your own feedback. I've given an example of how this goes wrong just as I talked it through. You try to scale up to prevent or mitigate some outage, something goes wrong with that scale up. Watching this happen in real outages, you too have seen this, I will almost guarantee. What responders do is watch the graph looking for something like CPU load to come down, and at some point, usually about 20 or 30 minutes later, they notice that they've been waiting long enough for a fix, that something must be wrong, and at that point, they go check the graph for the number of healthy pods running, or they query the Kubernetes API for the state of pods starting up, or they do both. But because they have to actively seek out that information about the state of production and anything blocking it from reaching that intended state, there's a delay in the response to the incident. Again, I will bet money that most of the folks in this room have seen this happen one time or another. And it's just so easy to fix. All we have to do is make it so that in the same place where you scale up, you get reporting back about whether production is changing. That's it, that's all we would have to do. After I request a change, there's some kind of automated polling in the UI that's intended for a user to be using, and direct feedback about whether the state's been realized, notifications that there's a problem. The trivially simple version of this, right, is just having the CLI give you a watch your pod start up at this link message, and then at least you know you're supposed to click it. You don't have to remember where to go find that information. Again, more active feedback is better here. We do want to be careful of noise, and I'm going to talk a little bit more about noise later. But knowing what's happening in the same place where you tried to make it happen is something we could solve. In a similar vein, we have what I think of as the fire at production control pattern. It's like intent-based, with the relatively subtle difference being that you're specifying a particular action, not an end state. So instead of specifying the end state of production, you say, I want to do this thing in production. Not a big difference. But you're still not getting any feedback on the results of your action. I find that this is really common in release systems. You or your automation say to deploy this build, the release system kicks off, and then some machines, are those machines behaving differently based on your change? Where would you see that? You're going to have to go look at your telemetry somewhere else, and you have to know that. Particularly not just have they broken, but did the change have an effect? So it really matters where the deployment is at in your system and what its direct effect is. So this is a real outage. We have a service that's implemented blue-green deployments. The particular order for that deployment looks like this. Number one, we scale down the green or canary instance to a small number of pods. We actually start with one. We roll out the new version to it, and we send it a very small percentage of traffic because it's running one pod. We gradually scale that green instance up, sending it progressively more traffic until it's getting 100% of our traffic, right? So now nothing's going to blue, everything's going to green. Pretty standard. We roll out the new version to the blue instance at full scale, and then we flip over to send 100% of the traffic to the blue instance. You might already see where this is going to go. Some automation, in this particular instance, paused the rollout before the cutover was made back to the blue instance. It tried, in Slack, to tell a human that there was an issue that needed approval before completing. But no human noticed that prompt because it wasn't in the same place that the rollouts are actually happening, and the rollout timed out. The system's working fine. All traffic's going to the green instance. We're running on the new version. Everything's great. And then a new rollout starts. And the first thing the new rollout does is scale the green instance to a single pod. That didn't go well. So you need to know the actual state of production in the same place you're about to take an action on it. We often fire these commands into the ether without knowing what production looks like before we do this. The rollout UI should not just show you the progression of the rollout. It should show you things like how many instances are running each version, how is traffic being load balanced. It should be built into the scale down action to make sure that a human sees that traffic is going to the pods you're about to scale down and how much. The next rollout shouldn't be able to start without someone actively acknowledging that the previous one failed. Yes, this will add more things that happen in front of you, but think about the cool part about not having to store that you have to go look at your telemetry every time you do a rollout in your head. Okay, so speaking of making sure someone knows the actual state of things, raise your hand if you send alerts to Slack. Yeah, that looks like more than half the room. No, keep it up if you're embarrassed. Oh, interesting. Most folks aren't embarrassed about the alerts that they're sending to Slack. Okay. Slack alerts are an anti-pattern. There's a lot of reasons for that, but one of the reasons is that alerts to your chat are a bad way to get explicit feedback. You can't tell for sure that anyone has seen the notification, whether anyone's taken responsibility for responding to it, or whether the problem has stopped. Nothing about a Slack alert or the moral equivalent, an email alert or a Teams alert or whatever, is going to give you that information. You saw one case of how alerts to Slack are a problem in our rollout system. Here's another one. I bet you've seen this outage. We have a team who are responsible for making sure that our various SSL certificates get renewed. Doesn't happen often, so they haven't gotten to automating it yet. One important certificate, one that mediated the ability of things in production to talk to each other, was about to expire. An alert was posted to the team Slack channel reminding them to renew it. Several people saw this notice and assumed that someone else was taking care of it. Actually, this is the super classic version, which is that there was a person on the team who usually took care of it, and he was on vacation. The certificate was allowed to expire. We had an outage. Again, I'm giving you one specific example of this, but you've seen this before. You know someone who's had this outage. You might have had this outage or a version of this outage that's very similar, right? Somebody missed the alert to Slack, or the alert to Slack was seen and nobody owned it. You had an outage. There's other ways that your alerting system can lead you astray with not enough feedback. In my prior employer, this is not actually at my current employer, but the way to page someone was to manually send an email, right? If you wanted to page someone manually, you sent an email to their pager alias. This isn't alerts to email. The email actually caused a real page in a real paging system to be created, and it made a phone make noise. We're just using email as the UI to page people. But we had an email outage. And the mail system responded exactly as a mailing system should when it has an outage. It accepts emails to send later. Once it was back up, it delivered those emails a couple hours later. But in the moment, it took a while to realize that no one was getting their pages because they weren't actually being sent. Fortunately, in this case, it was during regular business hours. Teams were able to get a hold of each other on chat once they realized that there was an issue. But the fact that you didn't know whether your page had actually been sent to someone and you were just assuming led to problems. You know the right answer here. Someone's told you this before. Alerts should go to a pager or a ticket queuing system that tracks them. Whatever UX you use to page people, it should come as close as possible to telling you whether somebody's phone actually made noise as part of that sending function. As close as you can get to that, you want to know, did a phone make noise when I sent this page? Okay, another fun one. Configuration systems that take values in absolutes or delta values that aren't clear about which one you're doing. I'm usually in situations where I intend to do something like add n machines or other resources to a system, but I have to give the total number of machines to run on, not how many more I want to add. And that means that I have to do some really simple arithmetic. It's really simple arithmetic myself. And the control system doesn't validate with me what change I've made. So it tells me, okay, I'm going to run 200 instances, but not whether that's more or less than the previous configuration. Again, this breaks in the obvious way. Responders expect to upscale, but instead accidentally downscale their service, sometimes vice versa. I do this by getting my arithmetic wrong, right? We're running 4 of these configurations, and they're all running 35 pods, and how many is that so that I can add to it? I have to do math. Like, I'm good at math. I'm an engineer, but I'm in an incident, I'm busy, there's a lot going on, people get this wrong, right? Or you might just not realize that it's a UI in absolutes instead of a delta if you don't use it often. You might say, I want to add 15 pods to every instance. And so you send the system plus 15, and it says, great, I'm going to run 15 pods on every instance when I was running 35. Whoops. Again, this is really simple to fix. Just tell you when you say what change you're going to make, whether what you're doing is adding 100 pods, removing 100 pods. That's all you'd have to do. And if you get this feedback as part of the command to make the change, you can stop it when it's the wrong thing. There's a more general pattern here. Any configuration change that doesn't show you the actual impact of that change before applying it can cause this problem. Many systems confirm the change that you're making, but they do it by just re-describing the change you've already input and not showing the effect of that change on production. It's really easy to explain this one in an example. So we have a product at Datadog that's designed to scrub sensitive data from logs. It works like these do. It matches patterns. It redacts them if they're found. A user, an internal user, accidentally added a pattern that redacted the letter E from all of our logs in production. They realized very quickly that they had pressed a wrong button, so it was only true for about 7 seconds, which was pretty good. But we have 7 seconds of logs we simply cannot read. They were allowed to do this by the UI without any kind of confirmation of how many logs they were affecting or having to directly approve some example message changes. Confirming something like you want to turn on XYZ redaction rule would probably have been better than nothing, but it doesn't tell you what you're about to do. And I have written some terrible regular expressions in my life. So showing me what the regular expression I just wrote is going to do in my real logs would be super helpful. It's also the case that you could add something that's volumetric. You don't want to do this all the time. You do not want to drown people out with alert fatigue. But being able to say, you're about to affect tens of thousands of logs per hour, here's some example impacted logs. You sure about that? Right? Not so much you're about to affect 500 logs an hour or whatever scale makes sense for the organization, but when it's a huge scale, maybe check in. There's other useful actions we took from this outage. This is not all just a problem of feedback, right? Certainly we should, and now we have, restricted the number of users who have access to make global changes in this part of the product internally. And we've implemented better restrictions to prevent testing in production. The reason this configuration actually existed and was turned on was that somebody had a test in production and it was still there. We prevent outages with defense in depth, not just single confirmation dialogues, but feedback helps. In general, users want to know and should know the impact of their change. How many machines, users, logs, database records are they about to affect? Above some reasonable threshold, require a confirmation. Give direct difference examples in the confirmation prompt if you can, right? Old log versus redacted log, user permission differences, because those can get very complex. Some helpful tips to think about showing users what values are going to change in the system. Again, really think about alert fatigue. Do not confirm normal, reasonable changes. That's not always going to save you if you ignore some normal, reasonable changes. You are much better off confirming the really big ones so that people notice the confirmation, because the confirmation only happens when you're about to do something crazy. Only the ones you expect to be dangerous, right? Are you going to affect the current user? Is a really useful thing to tell somebody who's making permission changes. Are you about to lock yourself out? Maybe just check in. What about particularly important accounts, right? So for example, at Datadog, we have an account that we use on Datadog to monitor ourselves. Probably a good idea to tell you if you're about to affect that internally. This absolutely requires thought and judgment. I am never, ever going to give you all permission not to be engineers who think about the work that you're doing. But this is one of the pieces that you should be thinking about. What feedback is useful to my user in the moment that they're using this tool? All right, I'm going to rag on the Kubernetes CLI again for a minute. Kubernetes has this really helpful feature where you can set the context. For instance, the cluster that I'm doing operations in. And the result here is that you take actions in that cluster without having it front and center where you're actually taking those actions. Again, a lot of CLI tools have this property. The CLI itself does this. By default, it won't even show you what directory you're in. They set a location or a context, and then any action you take is going to happen in that context for the rest of forever. This gets especially scary when you have multiple terminal windows with different contexts. Stop me if you've heard this one. An engineer's doing some work on a personal sandbox cluster, wrapped up that work, scaled the cluster to 0. except that in between the work on their sandbox and the work that they were doing when they wanted to close down the sandbox, they had gone and looked at some production stuff, which meant that the cluster that they scaled to 0 was a production cluster. And then we had an outage. An example in the same vein that I've definitely seen people do is deleting the test database instance, except you were actually logged into the production database. This outage haunts us anywhere that lets you set a context. You have probably heard this story before. You might have done this yourself. And then we can take actions, especially destructive actions, without making sure that you have situational awareness of what context you're really in. Again, this is a case where there's more than one solution worth applying, right? Reducing the number of engineers with permissions to scale the production cluster to 0 is a good idea. But some folks need some level of control of production, and accidents happen. We're only ever going to be human. We often include confirmation dialogues for destructive actions. Do you really want to delete the database? If so, type really delete the database. But we forget to include situational awareness. You know you're deleting a database, but you meant to delete a database. Did you mean to delete this database? GitHub actually does a great job here. When you delete a repository in GitHub, you have to type out the name of the repository you're trying to delete. You could just copy and paste it, but you still have to at least interact with the repository that you're trying to delete. It would be valuable, in my opinion, to go even further, include that actual effect of the change. This repository has N contributors and XYZ lines of code. There's this many nodes and this many pods currently running in this cluster you're about to delete. You're about to delete this many tables and they have this many rows. It's not necessary to, again, show confirmations of scale all the time, but past a certain threshold, when the scale is large, users probably didn't want to do that. If there's a lot of data, if there's a lot of users, if there's a lot of scale and effect, check in. Maybe your user's confused about where they are. In general, validation is valuable. I think that that's not too controversial. Unvalidated configuration is definitely a common way we cause outages as SREs. And as an industry, right? This can take a couple of forms. Configurations that are allowed to ship to production but are corrupted or unparsable. I've had that outage. As well as configurations that shouldn't parse. They don't define required fields. They define fields in conflict with each other. They accidentally use a default that isn't safe for this system. A good warning sign that you might have dangerous configurations, yes, this is real code, is that the enforcement mechanism for not setting variables in conflict with each other is a comment somewhere saying, go check this other file and make sure that these things aren't in conflict with each other. You don't have a parser, you don't have something that lints your configuration, you don't have something that processes whether it parses before it can go to production. Just a comment. Can't see how that's going to go wrong. I was originally going to talk about a different outage with configuration validation, but let's talk about CrowdStrike. For those of you who may live under a rock, on July 19th of this year, CrowdStrike released a security rule, which is a kind of configuration, instantly and globally, that caused any Windows machine running CrowdStrike to crash to a blue screen and stay broken until someone manually fixed it. They've released a full postmortem. This quote is from their postmortem. But the short version is that the system that validated the new configuration file was using different parsing and processing code than the system that actually read and used the configuration in production. This meant that the validator saw 21 rule parameters, said that was fine in their actual testing. But when the interpreter on the actual customer machine tried to access parameter number 21, it read out of memory. It read memory out of bounds because it only expected 20. And that led to a blue screen. This outage was, again, especially bad for reasons besides that there was a configuration parsing error. The practice of instant global rollouts for new configuration, which for those of you who don't know, I've learned a lot about security in the last 6 months. People who do security think it's a really good idea to push your configuration globally to all customers in 5 minutes. You will have some very loud arguments if you try to tell them that that's maybe not the best idea. And the fact that the configuration parsing was happening during kernel startup both hugely expanded this blast radius and impact. But again, fundamentally, the cause here is that your testing code and the code on production were not the same code. So you can validate your configuration against the same code that's running in production. It's that simple, and yet we don't do this. Use the actual parsing code in production, put it in a library, and run the tests with it. If there's multiple versions of that parsing code, which is going to happen because not every service is using the latest version, especially if some people are customers, you need to validate against every version you know is running in production. And because our configurations are complex, right, they've got layers of definitions, they've got overrides, that validation should once again give feedback as much as possible. Hey, when I run this configuration versus the previous one, here's the delta of what flags are actually changing so that you can confirm that you have the effect that you expect. All right, moving on to a different topic. I really love GUIs. I hate command lines. I think that they're terrifying. I can see a lot more information about what I'm doing on the screen in front of me. I don't have to remember what the command is. I can just find the button that says the right words. I love GUIs. But y'all, we write some terrible GUIs for engineers. They can be misleading, right? Things like confusing color coding, bad graph scales. They overwhelm us sometimes with unimportant information. I am as big a fan as the next SRE of information density, but there is a difference between valuable information density and here's a lot of noise on your screen. And they can make production changes that you don't expect them to. So this is from GitHub's admin UI. I'm sorry it's blurry. The reason is that this is actually very locked down, and so I had to get someone else to take me a screenshot. But this lets you control whether and how GitHub actions are enabled across your org, which is something that will happen after you submit a PR or after you submit a change, a commit, and it will check. It'll do things like run tests, or in our case, it does some SOX compliance stuff. There's 3 elements on this page that you can interact with. This dropdown lets you select what repositories actions are enabled on. These radio buttons describe what kinds of actions are enabled on those repositories, and there's a save button. So we had an engineer who was looking at our actions policies to figure out if we could solve a problem with that, and opened up that dropdown just to see what control actions were available. They reported back what they'd learned, they went on with their day. So while they were doing that, they had actually selected a different option in the dropdown, but that should be fine, right? They didn't press the save button on the page. Really fun fact about this particular page, that dropdown takes effect immediately. You don't have to touch the save button. The save button only applies to the radio buttons. We had GitHub Actions off for 6 hours. That was a cool day. Again, there's more than one thing to fix here, right? After this incident, we significantly improved our monitoring on the current status and state of GitHub Actions so that they will be off for a few minutes, not 6 hours next time. So someone will get a page if they're turned off. We already actually have really limited access to this UI. The person who is making this change is the sort of person who is supposed to have those permissions. They were being careful, they thought. We can't fix the UI in GitHub ourselves, but we've raised the problem with them. There is some conversation about making it so that in general, you just don't have to interact with this admin UI because it is kind of full of this sort of foot gun. Again, confirming here's the configuration change you're making and the volume of things you're about to affect can help a lot. But take the time, even for your really simple UI, even if you're hacking it together for some hackathon, find someone in the hallway and point them at it and say, does this make sense? What do you want to do here? If you have one, work with an actual designer. You will have to have conversations with them about the fact that engineers want information density, not white space. That's cool. But designers have an enormous amount of expertise on this kind of problem, things that go wrong in UIs, and we should be willing to take advantage of their knowledge. All right, one last one. This is going to be a little bit more subtle, but it's the result of the fact that all of our systems are deeply interconnected. Because of that connectivity, it's often the case that making a control plane change to system A can cause serious issues for system B, which is owned by some whole other team. If team A doesn't have feedback on the state of system B in their own control plane, you're going to have serious outages that are entirely self-inflicted. So again, an example. These are real services. I have redacted the names to protect the not entirely innocent. But team A has a cell-based structure for their system. Intake normally writes to a single cell. I've called it foo. The intake also generates a kind of dial tone, which we use to monitor the progress of data through the pipeline. Those dial tones are actually read by a different service owned by a different team, which takes action decisions based on whether those dial tones are being successfully processed. When the team operating service A needs to do a failover between cells, they double write for a period of time to give continuity to their downstream readers, all pretty typical. That double writing includes generating duplicate dial tones, right? During the failover, that means system B sees twice as many dial tones because now there's duplicated data. We had an incident. Team A needed to perform a cell failover, totally normal. In this case, service B was a little bit underscaled. It had a memory issue. They got paged. They started scaling up. They ran into an issue where the command in the runbook didn't actually scale up properly because nobody's ever seen that problem. But these teams weren't talking to each other about this failover. And so team A kept scaling up their double writing and eventually caused user impact when team B's service got entirely overwhelmed. It's actually a known problem with the interactions between these two systems. We had seen it before, so I felt real bad that we had it cause a user-facing incident. But without feedback built into the scale-up for team A, we're just relying on these two teams to remember to talk to each other. And humans suck at remembering to talk to each other. Why is the information just not in front of the operators in the moment? Both of these problems can be at least partially addressed, this problem, I've got another one later, can be at least partially addressed by making sure that your release or change monitoring do not care about the org chart. That's it, that's all you have to do. We updated automated release gates in Team A's system to specifically gate on the health of Team B's system. That means that Team A gets direct feedback and an automatic pause for their failovers when Team B isn't healthy. Here's another example of this one, where you can accidentally change configuration, again, in unexpected ways. So we had an intern who was experimenting with live configuration on our staging. So the live configuration is capable of changing running services immediately, right, without having to restart them or anything. Because of the work the intern was doing, they created a change that would intentionally crash any pods it was installed on. They created the poison pill change, they rolled it out to a couple of pods on staging, crashing as expected. Life is fine. Yes. Unfortunately, the configuration system was built to track the latest configuration globally, which meant that this change poisoned the global configuration as well. A bit later, somebody else made an entirely innocuous change and rolled it out globally, which rolled out the crashing change globally. And it made our entire staging instance crash. We did loudly praise the intern for finding this exciting change, this exciting problem. And again, the system here is simple. We take the configuration system and we make sure that it will pause in its rollout if things are crashing. It doesn't care who owns them. It doesn't care what they are. It says, hey, wait a minute, you had me start rolling out a change and now stuff is bad. I don't care who owns that. Maybe you should check. Okay, so what did we learn today? Aside from the fact that computers are hard and maybe forcing Sam to think was a mistake, I think that we can see that appropriate, timely, integrated user feedback in our control planes could make a big difference in preventing some outages. We are failing at this as a discipline right now. The fact that so many of us in this room have seen outages just like this, outages that closely rhyme with the ones that I'm showing you, and we haven't fixed them yet, we keep having these as an industry, has got to be some kind of call to action. We can do such simple things here. First, and I think most importantly, you want to build feedback mechanisms at the point of use that show the actual change being made to production. It feels really simple, and yet we don't do this. Show the user how production will change, including the delta from the current state, the scope of the effect, and specific examples of the change if appropriate and possible. If the change is large in scope, right, be sure to confirm it with the user with that context. Make sure the user knows where they are, particularly for anything destructive, doing things like typing the name of the repo if you're about to delete a bunch of stuff. Report that production has changed. Report the end results of that change as they happen. What is the current state of production? And do not force your user to remember to look for this data. Let us please offload that memory to robots. They are so much better than this, than my own precious brain meat. I need to learn every item in the binding of Isaac still. I don't want to remember that I have to go look at this stuff. Think about validation for your changes, right? Always be looking at the actual changes made for validation and always run the tests. Have basic parsing and sanity checks for your configuration before they can be applied. Make sure those checks are the same as the actual parsing done in production. Use the same actual code. A slow rollout, a canary with team-agnostic release gates, and pause the investigation pause and investigate if there's a problem. Even if the changes are slow or delayed, you need notifications and current state feedback that is front and center for the user when they need it, where they need it, without them asking for it. Telling users to always load this page before making changes to production is asking humans to be better machines. We don't do that. That's not what we do. If there is a problem holding up a rollout, send that alert somewhere it cannot be missed, just like every other alert that your system generates. Look for signs of surprise in your postmortems. You can head off a lot of these things, but knowing whether there is surprise in your postmortems ahead of time, knowing whether there is surprise in your postmortems can at least let you fix these problems after the fact. Think about how you can build informative and active feedback mechanisms to prevent future outages. A little feedback will prevent a lot of pages. The next time you sit down to write a control plane, even or especially, honestly, if it's just a quick CLI or temporary, take just a few minutes to build in a feedback loop. Future you will thank you. We will all be better SREs.